How are you, everybody who is watching this video? My name is Olenjolai from the beautiful, fantastic country, Tanzania, eastern of the African continent. I would like to take this moment to welcome you onto our online school, which is called Tanzania Online Advanced Secondary School in square bracket in Olenjolai. Simultaneously, I would also like to welcome you into one of our YouTube channels where we used to upload many videos which containing about the trainings on some of the scientific and mathematics subjects in this school. So it's called Tanzania Online A-Level Circuit School. Okay, in square bracket also OLENJOLAIM. Well, so it means that you can search this, you can just write this word on the YouTube search engine, that Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM, where that you have and will see hundreds of videos that we used to upload. So before we start our sessions, because we are in session 10 today or lecture 10, okay, we are in session 10 or lecture 10. So I would like just to remind you quickly about the visions of this online advanced school. First of all, we don't have a physical school at this moment. We just have an online advanced secondary schools, and we are dedicating our times on training and helping students who are pursuing advanced subjects, right? And then the main vision that we have in this program, we like to incubate some of the students who are real serious and have visions in mathematics and the scientific subject, especially physics and chemistry, and later on we'll be focusing on biology. And also we like to teach them how they can combine the classroom instructions with their spiritual knowledge of the Word of God in order to solve real life problems. So like to remind you, everybody who is watching this video, that our main visions or main objective in these programs is not to help students to pass for the exams. Our main objective to see our students when they are continuing their studies or after they graduate, actually that they can solve real life problems, because that's why we are going to schools. We're not going to schools in order to have certificates. We're just going to school in order to have knowledge and solve the real life problems. However, that one of our specific objectives, we help students to pass their continuous assessment, means their terminal exams, testing, midterm testing, annual exams, mock exams, next exams, which we call them advanced certificate secondary education examination. While physics, we are in departments of physics today, which is called advanced physics, and the subject is advanced physics, and this is the content for the Form 5 or Class 13. And the main topic is called the electrostatic. And the topic that you are focusing, this is the second topic of electrostatic, is called the electric force between the pointy charges. So that's the main topic that you are learning today. So now I would like to take you into the business which have made us to meet. And I'd like to start with a quick review. So this is the main topic. It's the first topic it's the first main topic, because I want just to remind you, in Form 5 or in Advanced Physics in Form 5, we have almost how many topics? 4. The first one is called Mechanics, which contain 11 topics. The second one is called the Heat, which contains 3 topics. The third one is called the Wave, which contains almost 4 topics. And the last main topic is called the electrostatic. And I have already told you almost the 9 sessions. This is session number 10. But also remember that we have sessions, or I've told you a session called session 00, which is called General Introductions of Advanced Physics, Form 5 and Form 6, where I gave you too much detail. So let us begin with a quick review. I want to link this session 10 or period 10 or lecture 10 with session 9. So in session 9, I've just pay a focus. It has been titled that pointy charge. Okay, pointy charge. So when you say that pointy charge, this is the way that you notate the charge. Okay, executes simple harmonic motion. So a pointy charge between, or one pointy charge, which is placed between the 2 point charge and execute a simple harmonic motion. So you remember. So let me remind you. I said, suppose here you have a certain pointy charge, and here you have another 20 charge. So this one, suppose that is Q1 and this one is Q2. So regardless of their charge, suppose that this is a positive charge and positive charge. So we have a distance between these two charges, and that distance we can call it D, right? So what happens? Suppose also you have a 30-20 charge here, and this 20 charge we call it Q3. And then we place at a certain point, suppose that this is point C. So if you place this 20 charge, because it's also positive charge, and according to the fundamental law of electrostatic, we say that like charge repel and unlike charge attract each other. So that fundamental law of electrostatic we learn since we are in Form 2 in the topic that called static electricity during the physics Form 2. So I'm reminding you. So we say that if this is a positive charge, which is we have to place at this point. So if you place now Q3 in between of Q1 and Q2, what happens? So then, because this is positive charge, so this Q1 is going to push Q3 in this direction, right? And then this Q2, which is positive charge, because Q2 and Q3 have the same charge or the same sign, it means that both of them are positive, and as you say that, like charge repel each other. So positive, so this Q2 also will push Q3 in this direction, right? So what happens? So now you find that this Q3, it will be executing the simple harmonic. Simple harmonic in which domain? This is the domain. For instance, I suppose that this is point D, and this is point E. So this point charge will be pushed in these directions, and then this Q1 also will push the Q3 going back. Means that will be go back to the point A. And then Q2 pushing Q3 back against to the Q1, and Q1 back against the point D. And Q1 pushes also the Q3 back to the point E. And E also pushes. So that's the situation. So it means that you find this Q3 is executing simple harmonic motion. It's just like a simple pendulum, because a simple pendulum is executing simple harmonic motion. So we solved one of example, which is basically it was example. I don't remember definitely that what the number of example, by the way. Possibly that maybe in the next lecture, lecture 12, I might say. So I said I solved the one questions which are required to show that the point charge first of all executes simple harmonic motion. And if this point charge executes simple harmonic motion, the condition for the point charge to execute simple harmonic motion, the acceleration should be directly proportional to the displacement, and should be direct toward the center. But again, we derived the periods of the point charge, which is between 2 point like charge, and also I left the homework for you to derive the formula for the frequency, because the relationship between frequency and period, frequency is equal to 1 over T over period. Okay, so that is all about the session 9. This session is still in this our YouTube channel, so you can search for this session 9, and then you can go through to get to much detail. So today in this session 10, which the last session for electric force between the point charges, we say that I'm going to solve some problems. So problem solving, and this is the one of the reference book, which I say that every student should have a questions and answers physics book. For example, this is Advanced Physics 2 Review, and it comprises questions of advanced certificate secondary education from 2006 to 2020. So this is, I told you, it's a very beautiful photo. It's all about electronics. And I told that I really like electronics, and these are discrete components, discrete and so passive and active components. So capacitors, you see this is a capacitor, this is the integrated circuit, this is all about capacitors. You see, this is all about capacitor. This is the fixed resistor, interesting. And then this is all about through-hole electronic components. So it comprises questions and also comprises solutions. So today I want to I would like to present some of the questions and show you what the weight, because the questions of electrostatic are the questions which ask often as question number 6 or question number 5 or 40 of advanced certificate secondary education. So it means that the main difference or the reference here, which you are going to use, is Advanced Certificate Secondary Education Examination, and this is paper 2. So electrostatic contributing questions of paper 2 after the review of the new syllabus and also the format of the final exam. And remember that I said we are focusing, or I'm focusing on the syllabus of United Republic of Tanzania. So we have a question right now, and with these questions you can say that possibly this is the example 15, I'm not sure, you have to cross-check. Okay, so this example 15, you have to refer Advanced Certificate Secondary Education Examination, paper 2, and the year it is 2018, right? If you have this review book, it's found in page 15. Page 15, okay? And I'm going to solve question number 6. I would like just to write, however, that it is also asking some concept which you did not cover yet in the main topic of electrostatic. So I would like just to show you that this is the book, and you see that this is Advanced Certificate Secondary Education 2018 Physics Paper 2. These are the constant. This is section A, and the electrostatic contribute the questions of section A. The last question is section A, but also it contains so many marks. So you see, so this the questions there's almost the part A, B, C, D. Okay. However, that you are going to solve on the part C. So let me write so you can see that what should you expect. Okay. So let me begin with the question number 6 in part A. So part A, the question says that briefly explain the effect. Briefly explain the effect of the electric material. Okay, the electric material on the capacitance. So I didn't teach you. Remember the last topic of electrostatic is capacitor. Okay, is capacitor. So it means that once I teach you capacitor, you may answer these questions. Capacitance. Okay, so this is capacitance. So briefly explain the effect of the electric material on the capacitance of a capacitor. Okay, of a capacitor. When the capacitor is, when I just want to show you the format of the question. When the capacitor is from 1 isolated, okay, isolated, and then from 2 when the capacitor is connected to the battery. When the capacitor is connected to the battery. Okay, that is all about part A. And then B, question 6B, say that how are the electrolytic capacitor made? How are the electrolytic capacitor made? So here's a question mark. So this is all about how do we make electrolytic capacitors, because we have 4 types of common electric materials. Okay, so capacitors made. So it means that that's all. So that is so for the part A of this question number 1 and 2, you cannot answer it, and I cannot even answer because I haven't taught you the concept of the capacitor. And then also part B, you cannot answer it, okay, because I haven't taught you about any types of capacitor, right? However, that you may use your knowledge of O level, if you still remember about the electric capacitor, if you learned about it, can use it. So part C, which is kind of interesting, where that I'm going to solve it, is stated 2-point charge, 2-point charge. You love physics? Tell me in the comment sections of this video whether you love physics or not, right? And I encourage you to love physics because physics is beautiful, especially advanced physics. I know that many students, they used to cry upon it, that it is difficult. But even yourself, I want to tell you, you're more intelligent more than the difficultness of physics. Okay? So 220 charges of equal mass M, right? And charge Q, and charge Q, and charge Q, okay? And charge Q are suspended, at a common point. At a common point, okay? At a common point. Common point by two threads. By two threads. By two threads of negligible mass. Of negligible mass. Negligible mass and length L. And length what? Length L. Okay, length L. And then the next sentence is if the 220 charge, okay? If the 220 charges, okay, 20 charges, okay, are at equilibrium. At equilibrium, okay? Show that, the distance of separation Acsee from N1, the distance of separation X is equal to, then we have interesting formula there of physics. This is Q square L over 2 pi times permittivity of free space multiplied by the mass times gravity, then raised 1/3. Okay? Raised 1/3. Raise my dust. So you have to show that the distance X is equal to quantity of charge Q square times length of the thread over 2 pi times permittivity of free space times mass of the pointing charge. And dg is gravity power 1/3. That is part 1 of section C. So let us go to part 2 because we have Roman 1 and I'm going to Roman 2. And physics is a beautiful subject. I would like just to remind you, don't forget that in your mindset. So Roman 2. And then the angle of inclination. Show that the angle of inclination. The angle of inclination beta. Okay, the angle of inclination beta. This is a square root of what? The square root of cube root. Now this is the cube root, not the square root. Cube root, this is the cube root of q square over what? Over 16 pi, permittivity of free space, then mass, gravity times length, square. Okay, square. That is all about part C. So we can solve part C Roman 1 and Roman 2. Why? Because I've already taught you all of its concepts. The concepts which are required for you to solve these two problems. Because you have to show the formulas and you see that how physics is beautiful. So then the question 6 has part D. However, that we didn't cover part D, but let me write so that you can see. 220 charge, this is the next topic, which is the third topic of electrostatic. 220 charges. 220 charges, QA is equal to positive 3 microcoulomb and QB QB, this is equal to negative 3 microcoulomb allocated 0.2 meter apart. 0.2 meter apart. Okay, apart in vacuum. Vacuum. Find from one's electric field at the midpoint of the line joining two channels. Electric field at the midpoint. Of the midpoint of the line joining two channels. The line joining two channels. That is part 1. And then part 2, the force experienced by the negative testing charge, as a negative testing charge of magnitude magnitude 1.5 exponential -9 long. Let's see at this point. Just at this point. Okay. So this is the question. This is how, or this is the question show you a sample or show you how the questions of electrostatic are being asked or tested to the student in the NECTA exams, right? So you see the questions comprises how many parts? 3 parts. Part A, B, C, and D. So let us read the questions quickly. Briefly explain the effects of the electric material on the capacitance of the capacitor when the capacitor is Roman 1 isolated, Roman 2 connected to the battery, Roman B. That's all about that one. So I will answer these questions when we cover the first topic, which is called the fifth topic, which is called the capacitor. Then B, how are electrolytic capacitors made? Also, we'll answer these questions once I teach you the fifth topic of the main topic of electrostatic, which is called about the capacitor. Again, the question number 60C is stated, 2-point charges of equal mass M and charge Q are suspended at the common point by the two straits of the negligible mass and length L, right? So 2-point charge. So if the 2-point charges are at equilibrium, show that, Roman 1, the distance of separations between the point charge is given as quantity of charges square times length of the straight over 2 pi perimeter of free space times mass of the charge times acceleration gravity, power 1/3. So this is within our capacity. I've already taught you this concept in different questions. And this also, it's one of the questions that I've already discussed about in one of the previous sessions of electrostatic. Roman 2, we have also to show the angle of inclinations beta is equal to cube root of q squared over 16 pi permittivity of free space times mass of the charge times acceleration gravity times the square of the length of the straight. Again, 6D. So we'll solve part C, Roman 1 and Roman 2. Part 6D. The pointing charges QA is positive 3 microcoulomb and QB is negative 3 microcoulombs are located 0.2 meter apart in vacuum. Find the electric field at the midpoint of the line joining two charges. Also, this question 6D, Roman 1, it all explains about the third topic, which is electric field. And once I teach you, now you will be able to solve this Roman 1 and Roman 2, the force experienced by the negative charge of the 1.5 exponent negative 60 coulomb placed at this point. So now let us solve part C of this question, right? In case you have any question about electrostatic, don't hesitate to ask in the comment sections here of this video. And students, advanced students, or even other students worldwide, or even in the nations of United Republic of Tanzania from any schools, they can answer. And even myself also can answer. So now we go for the solution. Solution of what? Example 15, as I said, possible. I'm not sure about number. Possibly I'm confused. Example 15, Roman C. And then let us start with Roman 1. We have to solve Roman 1 and Roman 2. So sequential. So let us start. So we say that in the question 60C, so it means these entire questions might find that it might be comprising, or it might be once you solve question number 60 from part A to part D, you may earn possibly 15 marks into 20 marks for paper 2. So it's worth for you if you solve it. So now let us solve this question and let us start with Roman 1. So Roman 1 will be given 32 pointing charges of equal mass. So it means the mass of the each charge. So possibly we might start this point that are given. Okay. First of all, mass of the charge. Mass of the charge. This is given as M. Just in notation. And then quantity of charge means that the quantity of charge. Okay, quantity of charge. In this, it has been explained or presented as Q. But again, that suspended at the common point by the two states of the negligible mass and length L. So length, so we say that length of what? Of the straight. Length of the straight is generally known as L, right? Negligible mass and length of that one. So if the 2-point charges S are at equilibrium, show that distance of separation, also distance of separation between the point charge is equal to what? Is equal to X. But also you have acceleration gravity, which is what? G, right? We have acceleration gravity, which is G. So acceleration due to gravity, okay, due to gravity, this is given as G. Just I want to interpret the letters. While also we have permittivity, if you do remember, in my sessions, I've taken permittivity of free space, of vacuum, This is given as new atoms, right? So it means that we've already defined every letter. So after defining this, I want to present these informations diagrammatically. And this is the first step. Okay, this is the first step. At the first step. So if you first step, then just you have to copy. You can pause the video and copy because I want to clean this part so that I can go to the second step of present the information geometrically. So think that you've already finished the copy. Now we are going to the second step because I want to leave the informations. I would like to sketch these diagrams to go for the second step together while we have the information displayed on the blackboard. So the second step, we say that let us represent the problem geometrically, right? Okay, in the figure. Let's say in the figure 10 below. So we say that suppose that this is the fixed point where we tie up our threads. This is the fixed point, right? And then we have two threads. The first thread is here, and the second thread is somewhere there, right? And then we say that here we have two point charges, which are lighted, right? And the distance of separation between them, which is this one, according to the questions, will be given as what? As x. So this distance separation is what? X, right? And then the quantity of charge of each charge is q. And then the mass of this pointy charge is m, right? And then here we have, you can formulate a right angle triangle like this. So, what the length of the thread, right? Does the question compare the length of the thread? Length of the thread? Yes, the length of the thread is L. So the length of the thread, on the questions, it's L, right? So if the distance between Q1 and Q2 is X, then half of the distance, this one will be X over 2. This will be the distance from the center of this pointy charge to the this symmetry line, right? And then also here we have X over 2, and this is the distance from here to here, just like that. Okay, X over 2. So at this point, the formation of the angle between the thread and this axis, and this angle, according to the angle of inclination, which is given as beta. So this is beta over 2, or this is beta, like that one. So I say that beta is beta over 2. No, it's beta. And also here we can formulate also a beta, right? A beta angle. So it can say that suppose this is point A, and this is point B, and this is point C, and this is point O. Okay? So we presented our information. What is next? So to present this information, we go to the next step. So we have presented our information geometrically. So we go to the third step. Do you enjoy learning electrostatic? Tell me in the comment section. So you go for the third step. The third step, we say that resolve the forces. Okay? Resolve the forces. So let us resolve the forces. So we can sketch this diagram now, but we can sketch this strategically. So suppose that this is the first diagram, and then here we have, okay, things that are expanded, and even just shorten like this, just for the amount of presentation. So here we have the pointing charge, and here we have the distance between this point charge, and this distance is called what? X, and then this is the length hour, right? So this is the length hour, and also this is the length hour. Okay, length hour. So then this is the point that we say this is better. Similarly, this is the point equal to beta. Okay? So here we say that this point is x over 2, and here it is x over 2. So now we want to resolve the forces. So to resolve the forces, this point charge has a mass. So here we have the weight mg, right? And also you say that also you have a force which is directed towards these directions, this we call T, because these are the like charge, and they have quantity of charge Q. This is either force of attraction or force of repulsion. But also if you resolve in vertical components like this one, so here we have a vertical components of force, and also here we have horizontal component of force. So suppose that this is point of charge 2. So the horizontal components of force, we say that the cosine of this angle, it will be in terms of tensions, if you consider, because this straight also, it has something, or it has a type of force, we call it tension. Okay? So it means that the horizontal component of force, we say that the sine of this angle will be opposite of hypotenuse, which is tension. So it means that horizontally, we are going to have tension times what? Sine of angle beta. For vertical components, if you are finding the cosine of this angle to be adjacent of our teeth, or to be adjacent of hypotenuse. So this vertical force, suppose that this is the length R, so this vertical force will be tension cosine of angle beta. So according to the question, we say that we have to show the distance between the two point charge is equal to the given formula. But when these two point charges are at equilibrium. So when at equilibrium means that these four forces balances. The downward force balances with upward force, and also the left-hand side force balances with right-hand side force. What does it mean? So you go for the forces tape. So the forces tape. Are you ready to enjoy the beauty of physics? The forces tape, we say that at equilibrium. So at equilibrium, we develop some equations. At equilibrium, we say that horizontal component of force, which is force of attraction or repulsion, this will be equal to the tension times sine of angle beta. Right? So this is the first equation. Simultaneously, also the upward and downward force balances. So where we say that the weight mg, this is equal to the tension cosine of angle beta. This is our second equation of the line. Wow. So if you have any question, don't stay ask in the comment section, where you have interaction with me and leave interactions with other students worldwide. Because no any limitations of the internet. So if that's the case, you got the fifth step after submission those questions. And the fifth step, we say that we can formulate the tangent. So we can eliminate sine and cosine and formulate the tangent. So you know that tangent of the angle beta is equal to sine of angle beta over cosine of angle beta. So if that's the case, to get the tangent, we have to take equation 1 and divide with equation 2. Right? So you can get equation 3. So it means that on the left hand side will be force of what? Mg. This is equal to tension sine of angle beta of what? Tension cosine of angle beta. Wow. So if this is the case, this is equal to tan of angle beta. Right? So if that's the case, we say that this is tan of angle beta is equal to force of attraction or repulsion of weighting mg. Okay? So if that's the case, we say that this is force is equal to mg tangent of angle beta. Right? So that the force. So tangent of angle beta. So this will be, or this is our equation 3. So if that's the equation 3, then we say that we got the sixth step. The sixth step, say okay, if this is the case, what the electrostatic? So we say that we call Coulomb's law of what? Of electrostatic. Okay, Coulomb's law of electrostatics. Coulomb's law of electrostatics say that force of attraction or repulsion, this is equal to K, okay, means proportionality constant, times quantity of charge 1, times quantity of charge 2, of what? Over square of the distance between them. But we say according to this one, these are the similar charges, so Q1 is equal to Q2, and this is equal to Q. Okay? So if that's the case, we say that if this is the case, you say that electrostatic force is equal to K, the quantity of charge square over radius square. So this is equation 4. So if this is equation 4, then that have to be, but we can clarify. Proportionality constant is equal to 1 over 4 pi permittivity of free space and then radius squared. So this will make that the electrostatic force is equal to quantity of charge square over 4 pi permittivity of free space and then r square. This is equation 4. Right? So we have equation 3 and equation 4. So we say that we go for the 7th step. The 7th step, we say that we have to substitute equation 4 into equation 3. Okay? So you have to, because here we have force is equal to Q square over 4 pi permittivity of free space, R square. And here we have force is equal to mass times gravity times tangent of angle of the inclination angle, which is beta. So if that's the case, so instead of force on this left hand side, we have Q square over 4 pi permittivity of free space, R square is equal to what? Is equal to mass of the charge times acceleration gravity, then times tangent of angle beta, which is angle of inclination, right? Physics is beautiful. So if it is the case, we are the physicists and you are a physicist, right? So we like to have equations and we like to learn physics in terms of mathematics. It makes physics to be beautiful. So now we have another equation, which is equation 5, right? So we have equation 5. So again, after having this equation 5, now we have to come back at this point. And this will be the 8th step. So you see the way that we solve advanced problems. We follow so many steps, but you enjoy each step. So the 8th step, now, we say that we have to consider right angle triangle, which we can name it as what? This is B, we say that as B, this is C, this is A, this is O. So right angle triangle, which is called the B, or which is called O, C, B, right? So if you consider right angle triangle, when we know the issues of tensions and etc., etc. So if you consider this right angle triangle, so now we can have a right angle like this. This is a right angle, simple. You learned right angle in Form 1. Okay, in Form 1 you have to learn the right angle. So this is what? This is angle B, and this is angle O, this is angle C, right? So then we have sides. Here we have an angle. So this angle is angle of inclination, right? Which is beta. On this side we have what? X over 2. And then here we have what? Length L. Length L, which is capital L. So because you have an angle, and this is the opposite side, so we can recall the concept we call the Pythagoras theorem, or Pythagoras theorem. So it means that now we say the sine of angle beta, for this case, the sine of angle beta is equal to opposite of hypotenuse, which is L, right? So it means that this one will be equal to x over 2 over L. So this is equal to x over 2 L. Okay? So that is the sine. Sine of the angle beta is equal to x over 2 L. So we got the 8th step. If we consider the tangent of the angle beta, in that case, the tangents will be opposite over adjacent, right? But we don't know the adjacent side. So we have to consider what the size of this angle, right? So we say that this is the 9th step. The 9th step, say the 9th step. So the 9th step, we say that we say we have to do estimation. For small angles, like this angle of inclination beta, right? We say that sine of that small angle, which is beta, is approximately equal to the tangent of that is small angle beta, right? Interesting, very important assumption. So if that's the case now, so for that case, means that sine of beta, which we say is equal to Acsee over 2L. So this is approximately equal to the tangent of angle beta. Why did I do this estimation? Because in the equation 5, we have tangent of angle beta, not angle theta. Excuse me. It's the mistake. Okay? It's the mistake. If I did it in previous thing, the angle is beta. I'm experienced to use the angle theta, so that's why that I've been writing for frequently. So do that correction. So for that case, you say that tangent of angle beta, this is equal to what? Is equal to Acsee over 2R. So Acsee over 2R, this is equation 6. Interesting. So you have equation 5, you have equation 6. So we have to go to the 10th step. We are still solving one question. Still solving one physics question. So we say that substitute equation 6 into equation 5. So it means that in place of tangent of beta, we have to put Acsee over 2R. So if that's the case, you have quantity of charges squared over 4 pi, permittivity of free space, and then radius squared. This is equal to what? Mass times gravity, and then you have Acsee over 2R. Right? So x over 2R. So this will make a fantastic equation 7. So we have 7 equations. Don't get tired, don't be disappointed. You chose yourself to study advanced physics. Nobody who has convinced you, nobody who has persuaded you, you chose yourself. So this is the beauty of the choice. Okay? So then we say that quantity of charges squared over what? Over 4 pi, permittivity of free space, and then radius squared. This is equal to what? Mass times gravity times x, okay, over what? Over twice length. So this is a simple mathematics, because remember the questions was asking us to show that the distance between the 2-point charge Acsee is equal to a certain formula on the right hand side. So this one we just simplify. We divide this by 2 both sides, right? So if you divide by 2, this will be equal to the quantity of charges squared over 2 pi, permittivity of free space, and then radius squared. This is equal to mass times gravity x over L. Then we got the last step. The 11th step. Say 11th step. Say the last step. 11th step, we say that make x the subject. When did you learn the concept of the subject? During your Form 2 in the topic called exponent and radicals. The first topic of the Form 2 in basic applied, in basic mathematics. So make x the subject. So we make this one x the subject. So we can interchange these equations, meaning that what you have on right hand side, we start on writing what you have on right hand side, and then we come to what you have on left hand side. What does it mean? We have mass times gravity times Acsee over what? Over L. This is equal to what? Quantity of charges squared over what? Over twice pi permittivity of free space times what the square of the mean distance between them. So for this case, you just cross multiplication and you make x the subject, and finally you have answered the question 60C of 2018, Roman 1 only, not Roman 2. So if you make x the subject, so it means that if you want just to simplify your life, we say that on this side we have 2 pi permittivity of free space r squared. Then we say mass L Q is this is equal to Q squared Q square times what? Times R. Okay, times R. Okay, so Q square times R. So then we say that we have divide is what? Is 2 pi, then T of free space, R square, then mass and Q, and this one. But we have, okay. So, okay, I know what I'll do. So you say that we divide by 2 pi, then T of free space, and then before we divide with this, I want just to comment something to correct. So this is the correction. The distance between two-point charge of charge Q, okay, is x, not R. So if that's the case, I want to do minor corrections. When I call the Coulomb's law, I say that Q square over 4 pi from T of free space R square. So this is the mistake. I have to say that this is x square. So if I say x square, in other words, from this formula, x is equal to R. So if x is equal to R, simply say that from that formula, you say that 2 pi T of free space, this is x cubic mg. Many students, they used to commit this mistake. That's why I have tried to make it and hence show students how we can rectify it. Okay? So now if we make x is the subject, we divide by 2 pi T of free space mg, and then we say that 2 pi T of free space, and then mg, because you should know the formula. So then, if that's the case, you say that x cubic is equal to q square times length of what? 2 pi T of free space mg. So then you have to find what? The cube root of x, and also on this side, you have to find the cube root of x. Okay? Beautiful. So the cube root of x cubic is equal to what? It's x. And the cube root of that formula, we can represent it in terms of indices. Means you can remove the radical signs and put in terms of exponent. So we say that x is equal to what? Is equal to the quantity of charge square, right? And then over 2 pi, the relativity of free space, then there's mass, gravity, and then we have length. Where is the length? Length is still here. Yeah, so we have length there, we have length, okay, fine. So here we have length, and this one is 1 over 3. Remember that if you have square root of x, this is equal to x in power half. If you are looking for the cube root of y, this is equal to y power 1/3. Remember the laws of what exponent. So then that's our formula, hence what? Hence shown. And this is the beauty of electrostatic. Say, hence shown as it required. Because the question asks you to show as required. So this is the answer of 40. Question 6C, Roman 1. Physics is beautiful, and this is still physics of the Form 5. We'll be together in physics of Form 6, and you will see how it's beautiful. Right? So good, great. So now we are going to solve question number 6C, Roman 2. You have to show that formula of angle 40 inclinations. You have to work very hard. Physics, advanced physics demands students who are really serious. If you are not serious, my friend, I would like to tell you that physics might become your enemy. Instead of becoming your friend, becoming your enemy. So you have to work hard. That's my advice. Okay. So in Roman 2, we have to show that the angle of inclinations is given as cube root of q square over 16 pi T of free space, mass of the charge, times acceleration gravity, length square. So it means that this is still a continuation. So we ended in step 11. So you can go to the 12th state. So in 12th state, we say that what? We say that, okay, so we have to recall. We have to recall. We have to recall what? We have to recall equation what? We have to recall one of the equations. I think that was equation 5, possibly, or equation 6, if I'm not mistaken. But simply recall the equation that we say tangent of angle beta. This is equal to what? Is equal to tangent of angle beta. It was equal to what? Is equal to x over 2r. Remember that questions? I believe that you still remember it. And then the questions ask us to show the angle of inclinations. But if you check that formula, you have to be careful, because the concept is we have to recall, or we have to use two formulas. Tangent of angle beta is equal to x over what? So it's equal to x over 2r. Okay, 2r. And possibly this was equation 60 or 7. Equation 7, if I'm not mistaken. I don't remember it well. And then we had another equation. And also we have this equation. X is equal to what? Is equal to q squared times length of voltage over 2 pi, derivative of free space, mass times gravity, and then 110. Okay? So this one, it will be equation 8. Equation 8. So you just have to use this formula. But when you are using that formula, you have to know the destination. The destinations we have to show that, the questions ask us, we show that the angle is equal to the cube root of what? Of q squared of what? Over 16 pi into free space, then mass of the point charge, gravity, power square. So this formula does not comprise the trigonometrical function, which is tangent. So we have to go to the, in the 12 steps, we say that for small angles, we say that tangent of angle beta is approximately equal to the angle beta. You have to remember this concept learned during your, especially in mathematics, in the concept of trigonometry. So if that's the case, we say that now we can formulate equation 9, which is beta is equal to x over 2l, right? Beta is equal to x over 2r. So this is equation what? This is equation 9. So equation 9. So this is equation 9. So we got the 13th step. Physics is beautiful. You have to start to enjoy it today. You have to keep enjoying it every day. 13th step. So this step we say that substitute equation what? Equation 9 into equation what? Into equation 8. Okay, so we have to substitute this equation into these equations and see how we can reach this state. That state we have already shown. So if you substitute, you have beta is equal to 1 over 2r, and then the value of x is this one. So you have to substitute x squared r over twice pi, permittivity of free space, then there is mass, gravity, and then power 1 over 3. Why? Because beta, this is equal to what? Is similar to say 1 over 2r times x. So the value of x is equal to this one, right? So then we have to simplify. So we have beta is equal to what? So beta is equal to 1 over 2r. And then so you have what? Cube root. Cube root of what? Q squared r over what? 2 pi, the material of free space, mass times gravity. So remember also, from a concept of exponent, if for instance we have, let's say it's 3, then radical of 4. This makes we say it is similar to say that if you want to insert 3 into the radical sign, then you have to square the outside number. So this outside number should be 3 squared times 40 times 4. Similarly, if example we have 3 and then we have a radical, it means cube root of 4. So if you want to insert this outside number, it will be 3 cubic times 4, because we have found the cube root of a certain number of 3. So times 40 times 4. This is a very important concept. So if that's the concept you are going to use, so if you have understood this transition, similarly here, we have to insert 1/2r in cube root of this physical quantity, of this formula. So it means that if we insert inside, it will be this quantity times 1/2r cubic. Right? Great. Okay. So, if that's the case, we say that here we have an angle beta. So an angle beta should be equal to what? This is equal to the cube root. It's equal to cube root of what? Cube root of, here we have 1/2r, as I said, but it should be cube root. Times what? Times quantity of charge square r of what? Over 2 pi, the material free space, times what? Mass times gravity. Right? So if that's the case, you say the angle of inclination beta, this is equal to what? Cube root. Say cube root. So cube root of what? So 1 cubic, it's 1, and then times q square r, that's numerator. 2 cubic, it will be 2 power 3 times cubic, and then times 2 pi, perimeter of free space, mass times gravity. Right? So angle of inclination is equal to the cube root. Cube root of what? Cube root of q square r over what? Over 2 power 3, it is 8. Okay? Times 40 times this 2. And then you have cubic, you have pi, you have perimeter of free space, mg. So this will make 16, but we can simplify 1L and 1L. So angle of inclination is equal to cube root, not the square root, cube root of q square as numerator. 2 times 8 is equal to 16. And then L over L cubic is equal to, we have L square in the denominator, times pi, times perimeter of free space, times mg. Wow. So then, if that's the case, we say that we have now managed to solve and show the formula required by the question. Okay? So it means that we say that beta is equal to cube root of what? Cube root of q3 over 16 pi, perimeter of free space, L square, mass times gravity g. So then, hence, shown. So that is end for question 6C, Roman 2. So we've been solving basically 2 questions. Interesting, right? So if that's the case, I would like just to reach the end of this session. So before I reach the end of this session, I have to leave the homework for you. Okay? So this will be example 16, and this is the homework 10. The homework 10. So the homework 10, you have to refer Advanced Certificate in Secondary Education Examination of 2016, question 5. Right? Question 5. Question 5. So it means that you have to refer Advanced Certificate Secondary Education Examination 2016, paper 2, not paper 1. Paper 2, section A, question 5. Okay, question 5. And question 5, it has 2 Romans A and C, but we can only cover part of A. We have covered part of A and part of B. So remember that this is Physics C, Advanced Physics C2 review. Okay, as I said, You can order this book, or the description of this video, you see how much does it cost. You can order and they can ship it in any regions of the United Republic of Tanzania. Questions and solutions of 2016 through 2020. Well, so let me rate a question quickly for you. So as I said that this is question 5, Roman 8, just three Romans. The first one, state Coulomb's law. State Coulomb's law. State Coulomb's law. Okay? Of electrostatic. I told you. How does it state? Electrostatics. Electrostatics. Then Roman 2. Roman 2, define electric field strengths. I will teach you the next week. Define electric field, the next topic. From lecture 11, so I will teach you about electric field strengths. Electric field strengths. Electric field strengths. Define electric field strengths, which is called the E at any point. E at any point. That's Roman 2. And then Roman 3, which is also we'll answer in the next topic of electric field. Mention 2 common properties of electric field. Mention 2 common properties. Common properties. Mention 2 common properties of electric field lines. Mention 2 common properties of electric field lines. Of electric field lines. Okay, so I will also answer in the next topic. Question 5b, which I want you now to do, is called the two identical balls. I taught you this question several times. 2 identical balls, and I left the homework for you. Balls of each, of mass, balls each of mass 0.8 kilogram. Okay, carry identical charge. And they are separated. By thread. The thread of equal lengths. Okay? At equilibrium, they position they are positioned themselves at a distance of 1.2 centimeter, as shown in figure below. In figure below. In figure 2 below. Figure 2, not below. Calculate. Do what? Calculate the charge. Calculate the charge. The charge in either. So let me draw the figure quickly again and the session. So we will meet in session 11 of electrostatic, where I will start a new topic which is called electrical field. And hence I will take you to the session 12, 13, 14, 15, 16, 17, 18, 19, 20, and so forth and so forth. So let me draw the figure 2 and then get prepared to end the session. I know that many students, they like this moment even if they understood nothing, because I have been a student, and also I was happy when the teacher just mentioned I'm about to finish the session, whether I understood or not. But I'm very happy. Why? Because the proper characteristics of the studentship. So here we have angle P, here we have angle 60. These are the very simple questions, but of course I've been solving it, and I gave it even a homework to you. So that's why that I wanted even to show you what I was doing. It is highly recommended in the final exam. So this is figure 2. Okay, figure 2. Okay, so just to go quickly onto this homework means that you state the coulombs of electrostatic, you have a capability. We said that coulombs of electrostatic, I state by using 3 reference. So remember session 3, hopefully if I'm not mistaken, session 3, when I've stated about Coulomb's law. How does it state? The force of attractions or repulsions between the 2-point charge is very proportional to the products of the 2-point charge and inversely proportional to the square of the mean distance or of the square of the mean distance between the pointing charge. And then question 5A, Roman 2, define the electric field strength. We will cover it when we vote the second, because it's the second topic, the third topic. Mention 2 common properties of electric field lines. I will teach you in session 11. So I will answer this question and these questions in session 11, because this is session 10. And then question 5B, interesting. This is your homework now. So your homework is at this point, this is homework 10. And also your homework here is this one, this homework 10, right? So I want you to answer question 5A, Roman 1, question 5A, and question 5, Roman B. Okay? 2 identical balls, each of them mass 0.8 kilograms, carry identical charge, and they are separated by the trace of the equal lengths, right? Separated by the trace of the equal lengths. They have equal lengths, right? And then at equilibrium, they are positioned themselves at a distance of 1.2 centimeter. So set one quantity of charge, another quantity of charge. As shown in the figure 2, calculate the charge in either one. That's all. I told you. Supposedly I have drawn it badly, because I'm using the blackboard, but you can draw it proper. That's why you should have a pencil, you should have a rubber, you should have a scientific calculator, because for this case, you have to compute and calculate the quantity of charge. And it's very simple. Just a review of example 15, which I've already done, but there we have been using letters. Here we have numbers. So you know that physics, which uses letters, is a little bit difficult compared to the physics which uses numbers, because numbers is very simple. That's why that people, we are not numbers, we are just using numbers, right? So that's the end of session 10. I would like to thank God who have been with me in the preparations of these sessions and even during the presentation. I thank you also, my dear viewer, my dear students, who have been with me from the beginnings of these sessions to this moment. I believe that you have so many questions, and I like your questions, and you can ask by using the digital platforms. I say that you can use the comment section here at this moment on YouTube, and even once we have other platforms such as social networks, we'll be inviting you to ask your questions in different ways. But currently, use the comment sections in the YouTube media so that we can interact and even interact with some other students. I would like to invite you in session 11. Make sure that you don't miss, because I will start a new topic with the same topic for electrostatic at the main topic. So don't miss it. I'll build the strong foundations to be possibly a long sessions. I will break it down consecutively according to the contents that we are going to cover, but get prepared to enjoy it, because I will try my level best to simplify, take complex ideas and make them simple and simple and simple, so that you may enjoy advanced physics and you may enjoy yourself, your expectations of being a scientist or an engineer or a doctor of medicine or a pharmacist, regardless. But remember that the main objective of myself to do this program is I want to see my students, when you are studying and even after you graduate, you go back to your village, to your street, to solve at least a single problem for the rest of your life. So see you in the next lecture. May God bless you. I'm praying for you, pray for me. See you in the next lecture.